Hi, welcome back. In part one of our series, we're going to go through the process of using Cluster API for vSphere to provision the Bootstrap and management cluster in our VMware on AWS environment. So let's have a look at the environment we're going to use. So I have a Jumpbox virtual machine in my on-prem vSphere environment that I'm going to use to deploy our workloads into our VMware Cloud on AWS environment. So let's take a look at the Jumpbox and kind of what tools we're going to use and what actually comprises the Jumpbox server. So the Jumpbox is just a virtual machine running Photon OS. It can run any Linux operating system for the most part in my on-prem data center. So we are utilizing Kind or Kubernetes and Docker as the Bootstrap cluster. So Kind is a tool for running local Kubernetes clusters using Docker containers as nodes. So this allows a developer to spin up a quote-unquote Kubernetes cluster on their laptop without having to worry about provisioning additional infrastructure to act as worker or master nodes. Kind essentially uses Docker containers as nodes of a Kubernetes cluster. So this was primarily designed for end-to-end testing of Kubernetes builds, but it's also really useful for a great tool for testing Kubernetes and playing with Kubernetes and testing applications deployed in clusters on your local workstation. So prereqs required for Kind on the Jumpbox, Go binaries, so Go programming language is used. The Docker engine has to be installed and configured, so Kind uses Docker as the nodes for the cluster that it spins up and manages. And then the Kind CLI binary or the CLI tool needs to be installed as well. So the additional tools that we're going to use on the Jumpbox from the command line to interact with the Cluster API environment, the first of which is clusterctl. So this is a command line tool used for bootstrapping the Cluster API for vSphere, or CAPV as we'll call it, management cluster. So this is not required to use Cluster API or CAPV, but it just makes everything a lot easier, and it makes bootstrapping the cluster a lot easier than doing it manually. So we're going to use Kind as the Bootstrap cluster. So clusterctl will use Kind to provision the Bootstrap cluster on the Jumpbox VM. And then obviously Kind uses Docker as the nodes for the local cluster on the Jumpbox VM. And lastly, we're going to use kubectl, which is the command line tool for interacting with the Kubernetes API. So kubectl is required for clusterctl. Clusterctl uses kubectl to communicate with the Kubernetes resources. So the first thing we're going to do is deploy our Bootstrap cluster, and to do that we need to create an environment variables file that includes things like the IP address and username of our VMware on AWS Cloud vCenter appliance. We also need to tell CAPV which data stores to use, which networks to use. So all of these variables that are defined in this file, my data center, my data store, my network, my resource pool folder, as well as the template. So this is the machine template or the virtual machine template in my VMC environment that CAPV is going to use to create all of our Kubernetes nodes whenever we're creating clusters. And then finally, we can also set an SSH key, so if we need to SSH into the clusters for troubleshooting purposes, or down the road if we want to manually interact with the clusters at the OS level, we can use this the private SSH key pair to interact with the cluster. And then we also define the version of Kubernetes that we want to utilize, so that when clusterctl uses this file, it understands okay, this is the version of Kubernetes that I'm deploying in the Bootstrap cluster, and then going forward, when we create manifest to create management and workload clusters, that is defined in the manifest as well, so that CAPV understands, okay, these workload clusters needs to be version 1.16.3 of Kubernetes. There are other optional variables that we can define here, things like memory, CPU, disk in gigabytes, as well as the service and cluster IP CIDR as well, if we want more control over how these clusters are deployed. So Cluster API for vSphere provides a Docker image that helps us create the scaffolding of YAML files to create our management cluster, our Bootstrap cluster, our management cluster, and our workload clusters as well. So we'll use this Docker run command and pass it the environment variables file that we created, as well as the name of our management cluster. So in this case, I'm using our VMC environment in the EMEA region. So I'm going to call this cluster my capv EMEA management cluster. So the Docker command runs and it spits out a series of YAML files that we'll use with cluster.ctl to create our Bootstrap and then management cluster. So now that we have our scaffolding of YAML files, we use cluster.ctl to actually create our Bootstrap cluster. So we pass the cluster.ctl command all of the YAML files that were just created by our Docker image, and we also define the kind of Bootstrap cluster that we want to create, which is kind. So this creates a Bootstrap cluster on our jump box. We look at the output from the command. We're preparing the Bootstrap cluster, applying the cluster API stack to the cluster, and then applying the provider component. So all that vSphere specific information we're applying as well. So if we look at our diagram, now we have a Kubernetes cluster in the Bootstrap cluster instantiated on our jump box. So now we're ready. Cluster.ctl is ready to move on to the next step. So now cluster.ctl instructs the Bootstrap cluster to create the control plane virtual machine in VMC. So this is the VM in our VMC environment that's going to serve as the management cluster. So if we have a look at the output of our cluster.ctl command, we're provisioning the target cluster via the Bootstrap cluster. So we're using the Bootstrap cluster to provision the management cluster, and we're creating the machine in VMC. So if we look at our diagram, now we have a new VM in our VMC environment that will serve as our capv management cluster. So now that we have our virtual machine in VMC that will serve as our management cluster, we're ready for that pivot that we talked about in the previous lesson in depth at Cluster API. This is essentially taking the Cluster API management stack from the Bootstrap cluster on our local jump box and then migrating that over to our management machine that we've deployed in VMC. So if we look at the next set of output from the command, we're pivoting the Cluster API stack to the target cluster, applying the API components to the target cluster like we did with the Bootstrap cluster, and we're pivoting the Cluster API objects from the Bootstrap to the target. So we're essentially moving everything from the kind cluster in our jump box to the capv management VM that we've deployed in VMC. So if we take a look at our diagram, we're using the Kubernetes components in our jump box to deploy those services in our capv management VM. So now, at this point in time, we essentially, for a brief moment of time, we have two management clusters. We have the jump box or the Bootstrap cluster on the jump box server, and then we have what will be our management cluster moving forward in VMC. So at this point, cluster.ctl realizes that the pivot has been completed. It gives you information about where to access the config file for the management cluster in VMC, and it deletes and cleans up the Bootstrap cluster on kind. So the kind cluster disappears, and going forward, anytime we want to interact with Cluster API to provision workload clusters, we will use the kubeconfig file and kubectl to communicate with the management cluster in VMC directly. So that concludes our part one of our series on Cluster API for vSphere, where we walk through the process of creating the Bootstrap cluster and management cluster in our environment that we'll use in part two to provision and manage workload clusters.